Hello and welcome to day one of exam review for physical science. This is Miss Walton coming to you from room 405 in the science hall. As you go through this week's review, there will be some questions that pop up in the video, and when you answer it, it'll give you immediate feedback as to whether you were right or wrong. These answers get reported to your teachers, but the reason that they're in here is for you to practice reviewing. So if you happen to get a question wrong and you're not immediately sure why, be sure to raise your hand and ask your teacher. If there's anything in these videos that doesn't make sense or that you would like further clarification on, also ask your teacher about that. So on day one, we're going to talk about matter in the periodic table. So here we go. If you recall, matter, it is anything that has mass. Excuse the interruption there. It's anything that has mass and takes up space. That also means that it has volume. It also comes in 4 phases. What are our phases? Well, we have solids, which are tightly packed, slightly vibrating, and we have liquids, which are less tightly packed. They're vibrating a little more. We also have gases, and last but not least, we have plasmas. So we're going to review those a little bit. Bear with me as I'm working on a computer here. Okay. So let's talk about what each one is like. First of all, we have solids. They have a definite shape. Their kinetic energy is not non-existent, okay, but it's pretty low. And they also have a definite volume. If you look at this solid down here, you can measure its length times width times height to get its area and its volume, in other words. So we're able to get our volume for that solid, and we're also able to say that it's a cube and that's its shape. But we know that it doesn't have no kinetic energy. It has a small amount. Everything's vibrating slightly. Now let's move on to our liquid over here. Our liquid takes the shape of the container. Think about pouring milk from a jug into a cup. It takes the shape of the cup. It has a medium kinetic energy, but it still has a definite volume. The volume is for sure however much space it's taking up inside that container. What about a gas? Gases have, they fill up the container. That's the type of shape they have. They have very high kinetic energy, and their volume is variable. Okay, it's not definite, not a definite volume for our gases. So if we think about the differences between solids, liquids, and gases here, we can think about changing from one state to another. How did we go from a solid to a liquid? You might say we heated it up, which is one way to do it. But what we really did was we increased the kinetic energy. We went from low kinetic energy to medium kinetic energy. And then we wanted to go from a liquid to a gas. So we went from a medium kinetic energy to a very high kinetic energy. Which state have we not talked about here in our table though? Plasma. Plasmas have incredibly high kinetic energy. It's electrically charged matter, okay? And that is a completely different ballgame when we're talking about matter. How can we create or destroy matter? Well, it can't be created or destroyed. Think about the law of conservation of mass. And what it says is that even if we burn a log, we are not destroying matter. We're only changing the form of it. We're going from wood to ash and smoke. We're not destroying anything. We're just turning it into a new form of matter. So think about our changes of state here. Let's start down here with our solid. Our solid had what kind of kinetic energy? Low kinetic, high potential energy. And if we went from a solid to a liquid and we melted our ice cube, we increased one of those. We increased our kinetic energy and lowered our potential energy. I went from a definite shape and volume to a definite volume and something that takes the shape of the container. What if I went back the other way and I lowered my kinetic energy? I would freeze it, and it would go back to having both a definite shape and definite volume. Now let's go from our solid to our gas. If I go from a solid, which has a really low kinetic energy, to a gas with a super high kinetic energy, I'm going to experience sublimation. This is a change that occurs in dry ice, when frost collects on a windowsill. That's the process here between a solid and a gas. Big energy change. Now what if I'm over here at my liquid again? I'm at my liquid. It has a definite volume, but not a definite shape, and I want to increase the kinetic energy to turn it into a gas, so I evaporate it. Now my kinetic energy is really high. My gas is going to fill up whatever container it's in, and it's not going to have a definite volume. I can compress it, I can change the volume of it. If I go back from a gas to a liquid, it's going to be an example of condensation, and when that occurs, my kinetic energy is lowering and my potential energy is going up. In any of these cases, did I destroy matter? I absolutely didn't. I conserved my matter. All I changed was the state it was in. If we added plasma on here, it would come off of gas and it would show an electrically charged particle. Okay. So when we think about matter, we have to be able to classify it, and we have to be able to say what type of matter we have. Well, you've seen the graphic organizer a million times already this semester, but the best thing to do is to memorize it and write it on your periodic table or your reference sheet during the final exam, because then you'll never mess up the way this thing is organized. So let's think about our types of matter. We start at the top here with matter. How did we define matter? We said it was anything that has mass and takes up space. Then we ask ourselves, can it be physically broken down? In other words, did I have to do a chemical change to it? Which we'll review here shortly, but just to preview on that. Remember, chemical changes are when I can't get it back, and physical changes are when I can get it back. So if I can physically break it down, it's easy. Okay, I can separate things or take it apart. But if I chemically break it down, it's not easy to put it back together. Okay, so if matter cannot be physically broken down, and I answered no here, it means I had to chemically break it down. That means I had a pure substance. So I can't break it down physically, I can only break it down chemically. And in order to do that, okay, I can put it in two more categories. If I can break it down chemically, if there are bonds to be broken, it's considered a compound. If there are no bonds to be broken, it's considered an element. It's really easy to tell the difference between these two because you have your periodic table on the final to use. So if it's made up of two or more elements chemically bonded or joined together, like H2O, CO2, NaCl, that's a compound. If it's not, and you find it on the periodic table, it's only one element, it falls under elements. So that's like iron, carbon, oxygen, when they're hanging out alone. Make sure, oh, here's a couple examples. Water, sodium chloride, and my elements are hydrogen, chlorine, zinc. Guess where I can find all this information? The periodic table. So you can automatically narrow down some answers by just saying, is it on the periodic table? And if it is, it has to be under pure substance. It's just a matter of, is it lonely or is it paired up? If it's paired up, it's a compound. If it's lonely, it's an element. Use your periodic table. Okay, what about the other side? Anything that has mass and takes up space is matter, but if I can physically break it down, then it's a mixture. And I define a mixture as anything that can be separated physically. But there are multiple kinds of mixtures. I have homogeneous mixtures, or homogeneous, however you say it, and heterogeneous or heterogeneous mixtures. Both are proper ways to state it. If it's a homogeneous mixture, it's evenly distributed. If it's a heterogeneous mixture, it's unevenly distributed. Homogeneous, homogeneous, can't see the difference. Heterogeneous, heterogeneous, can see the differences throughout. Some good examples. Can you see the difference in Kool-Aid? Not if you mix it up well. Can you see the difference in ocean water and salt water? You can't, so those are both homogeneous. And I can see the difference in trail mix. I only want the M&Ms in the trail mix. I don't care about that other stuff. I can pick them out. I don't want those tomatoes in my salad. I can take them out. I don't want sand in my water. I can filter it out. That makes it a heterogeneous mixture. So underneath homogeneous and heterogeneous, I have some other forms of mixtures. First of all, I have a solution. Solution falls under homogeneous. My arrow just disappeared here. And then in my heterogeneous, I have suspensions and colloids. If you remember, a solution is evenly distributed and has some evenly sized particles. Good examples are salt water and sweet tea. Certain parts of the water aren't going to be saltier than other parts. Certain parts of the sweet tea aren't going to be sweeter than other parts. It's evenly distributed with those evenly sized particles. A colloid is evenly distributed and has multiple sized particles. The good way to remember this is that light will not shine through. Colloids are cloudy. So because they're cloudy, it's a good way to remember what a colloid is. Milk, fog, paint, these are all cloudy substances. That makes them colloids. Another example is mayonnaise. Those are all colloids. How about a suspension? Unevenly distributed. You can see the difference. So in a suspension, we could have sand and water where the sand settles to the bottom, muddy water where the mud or dirt will eventually settle out. You could also consider a suspension to be like a fish tank where all the rocks are at the bottom and the water is above the rocks. Now, we mentioned it for a minute, but we have some examples of chemical and physical changes we could think about. So we're supposed to ask ourselves, can we get it back? If we can get it back, it's physical. If we can't get it back, it's chemical. Another question to ask, did I create something new? If I did create something new, it's chemical. If I didn't create something new, it's physical. So, if I can't get back the original materials, it's chemical. And if I made something new, it's chemical. I know I have a chemical change if at least one of these things are produced. A precipitate, which is two liquids forming a solid. Gas, which is indicated by bubbles. Not boiling though. Bubbles produced without heat. Color change can be chemical, but not always. Think about Kool-Aid, which is physical, versus rust, which is a color change. Reactivity, some sort of reactivity like heat that's produced without any warmth being applied, light being produced like fireworks, bubbles, etc. And always if something catches on fire, it's a chemical change. How about on the physical side? I can get it back and I didn't make something new. I can also observe all these things without changing anything. I can say that my shirt is green without changing my shirt. I can demonstrate that something's malleable and can be bent without changing it. I can shatter a light bulb and it's still glass because it's brittle. I can measure the density of something and I didn't create anything new. So the best way to approach this is to remember these easy 5 things over here, because if any of these were produced, it was definitely a chemical change. If not, it was most likely physical, but don't forget to ask yourself those quick, easy questions. Can I get it back, and did I make something new? Great questions to ask yourself for chemical and physical changes. Okay. Those are circled because that's the easiest way to remember what chemical changes are. So much easier to remember those 5 than to remember the 9 on the other side. How about density real quick? Density equals mass divided by volume. Our units for density are grams per milliliter or grams per centimeter cubed. The units for mass is grams and the units for volume is milliliters or centimeters cubed. What does density literally mean? It means how tightly packed the molecules are inside of anything. Think of something as being tightly packed or heavy in a small space when you think of density. And remember, here's our equation. Density equals mass divided by volume. So if I have density and volume, I'm going to multiply to solve for them. If I have mass and density, I'm going to divide. And if I have mass and volume, I'm going to divide. Always solve for your unknown. What's the most dense item here? Definitely honey. What's the least dense item? Lamp oil. This is a great way to think about density. Least dense on top, most stints on the bottom.